Topic analyze math and history, and we're gonna talk about no man's land. So, in the past video, we have been learning about how to graph inequalities when they are linear. So, we've also been reviewing what happens when we have two inequalities graphed that will become areas, and we'll be able to make two of the equations be satisfied when we have a point that is marked in the area that the two overlap each other. Putting dots and points and areas in here or here in just one area will only satisfy one equation, but make the other one not true. Putting the area or putting the dot in no association, none of the equations are true. But putting them in an area where the two of the areas overlap will make both of the equations true. So that's why we're going to graph the inequality. X has to be less than or equal to -8, and x has to be greater than 8. So, will there ever be two inequalities that meet? Well, usually when we try to solve these, we have to simplify them. But wait, they're already in their simplest form. There's a variable on one side, and a number on the other side, and some sort of operator symbol in the middle. So the only thing we have to do is graph them. So let's graph them. Will they ever meet? Oh, and yeah, we're going to be using Desmos for this. So, on the graph, the first equation was x has to be less than or equal to -8. So we're going to put that right over here. We're going to write is x is going to be less than or equal to -8. And when we do that, we get a shaded area that includes the number -8. And when we zoom out, that means that anything that is less than or equal to -8 will be an answer for this inequality. Let's try the other one. X has to be greater than 8. So on the bottom one, what we're going to do is put the inequality x has to be greater than 8 and see where that goes. But this time, we get another shaded area. And instead of a solid line, we have a dotted line because it's not including that 8. Any number that can be inserted in for x has to be more than 8, like 9, 10, 11, 12, 13, 14. So when we zoom into that area, the line is dotted instead of having a solid line. So, looks like we have an answer right here, but it doesn't really seem to be an answer because normally when we are trying to understand graphing linear inequalities, we are trying to look for two areas that overlap and merge together because, what we said earlier, the rules of the game say that when you have a point that are in two areas at the same time, they will satisfy two equations. Putting points in the area for one side or this side is going to satisfy one equation, not two. And putting them in the no association area, no equation is going to be true. So, what it looks like from here, it looks like that the two areas don't want to seem to merge, which means that there is no solution. We could put a point here where this mouse cursor is, but it's not going to satisfy two or at least one of the equations. If we put one in the red zone, then it will satisfy one equation, but not two. And if we put one in the blue zone, the same thing happens. It will satisfy the blue equation, but not the red equation, or two at the same time. So we can say that this inequality question that we have been taking a look at, we're going to say that there is no solution. There is no solution, or we can't really solve this problem. But trying to see what the graph looks like and finding the shaded area, the graph actually looks more beautiful because there are many colors in just black and white. And this kind of reminds me of something. This kind of reminds me of the Vex Robotics game, Tipping Point, because if you have a mobile goal in the white area, that means that no points are awarded for either side. Putting the mobile goal on one side will award them points, but not for the other side, and vice versa. Here are the game rules.
The object of the game is to get more points than the other alliance, by scoring rings, moving mobile goals to alliance zones, and by elevating on platforms at the end of the match. The VRC Tipping Point field consists of 72 rings and 7 mobile goals. Each alliance has 2 alliance mobile goals, with the remaining 3 goals being neutral. Each alliance also has a platform located in their home zone. Rings are 4.125 inches in diameter, points each. Rings that are scored on an alliance mobile goal will count for the respective alliance regardless of where it ends the match. However, rings that are scored on neutral mobile goals will only count for an alliance if the mobile goal ends the match in their home zone. Each mobile goal scored in an alliance's home zone is worth 20 points, plus the points for any rings scored on that mobile goal. As the match draws to a close, robots will start.
So that was an instructional video on how to play the Vex Robotics game, Tipping Point. And that was a video actually made by Vex Robotics. So, what the 2 areas look like appear to be the 2 home zones on the graph or on the field. So, when they don't merge and there is something called no man's land, they're not merging, there is no solution. I hope this video has helped you understand what a no solution graph looks like when you graph the inequalities. Thank you for watching Helping Your Life's Math Industry. Like and subscribe. And to end the video, let's watch an actual Vex Robotics meet, Tipping Point.
Autonomous in 3, 2, 1, go! That's going to be blue so far. Oh! It's going to show up just a little bit. Very nice, very nice.
Alright, stars and garbage.
That's the blue outs on guard control. 3, 2, 1, go!
I don't know where they are. Roger that.
No! Someone!
Watch your cable over there. Watch your cable, please.
Cable! Hey, watch your cable!
Watch your cable.
There we go. E1 with the cable.
Mr. Eric Savorsky is in the house. Thank you so much. Danbury High School's one and only.
Someone gone!
Savorsky.
Hey, you were hard on that platform.
Lovely house. Thank you. It's a wonderful, wonderful opportunity for all these children. Seconds, 30 seconds. Please report to your appropriate side. 30 seconds.
I don't know. Get up there. Yes!
Well balanced. Nice. Muy bien, muy bien. It's right there. Came late to the show. You gotta listen. Queuing, 10 ahead. Queuing. Get to queuing. Problem solved. Here we go. Next match.